I'm Ren. I'm an engineer at Electric Capital, and today I'll be walking through the state of audits. So smart contracts are unique in the sense that it's kind of one of the first cases where we have all of the production code predominantly open source and transparent and running on chain. So what you get is this massive graph of cross-contract dependencies and rich data that is really valuable for both users and security researchers. However, one of the difficulties is publicly linking the contracts with the audit histories, which actually we believe will make protocols safer to use and easier for security researchers to dig into potential cross-contract impacts. But today there's a problem with the audit space because there's a large gap between audits and deployed contracts. Because in the workflow of engineers and smart contract developers today, audits happen pre-deployment. But most of the users, what they actually care about is the contract that's on chain. And linking the gap between the deployed contracts and the audit reports that are done pre-deployment is extremely expensive. And we actually find that a lot of security researchers, they spend the majority of their time reconciling commits with deployments instead of looking for bugs. So as a result, we went out and we collected pretty much every audit report on Ethereum since 2018 in Ethereum DeFi, and we open sourced this in the first version of the crypto audits mapping. We collected audit reports of a representative sample of Ethereum DeFi representing greater than 92% of Ethereum TVL since 2018. But just collecting these audit reports is very challenging. There isn't a very clean or easy process to do so because if you start off at DeFi Llama, what ends up happening is you end up going to the protocol website. Sometimes you go back to the auditor website, but eventually around 71% of these audit reports end up living on GitHub. But these audit reports, most of these audit reports today are in an unstructured format. They're predominantly PDFs, which means parsing them and extracting information, valuable information from these audit reports is actually quite costly. So we tried out so we built embeddings across these PDFs using GPT-4, and we subsequently asked a series of classification type questions, such as what is the name of the auditor? Can you give me the critical risk findings? But more importantly for us, we were really looking to link the audit reports with the contracts that are deployed on-chain, and more importantly, the repositories in themselves. One of the interesting findings that we found, which should be pretty common sense, is that the larger the TVL of the protocol, the more audits these protocols tend to get, with protocols larger than 1.1 billion in TVL averaging around 10.6 audits with a median of around 4 audits. So protocols in the space are using audits, but we think that there is still this gap between the audit reports in themselves, the GitHub repositories, and the actual deployed contracts. Luckily, most audit reports have references to a Git repo or a commit hash, so that solves the first link. But it gets a little bit messier when you actually try to, as a user of DeFi protocols, to link audit reports with the actual deployed contracts, because one thing that tends to happen is you tend to get a lot of audit drift between the time of the audit and the code that's actually deployed, with less than 2% of audit reports actually referencing the deployment addresses. And that's really concerning from a user perspective. And it really highlights this large gap in the current workflow between audits happening pre-deployment, but most of the users only really caring about what's actually deployed on-chain, because that's what's actually custodying the value. And as a result, we kind of see that most users, instead of referencing audit reports or really reading the audit reports in themselves, they end up falling back to a measure of lindiness of a protocol to determine if it's secure and whether it's secure enough for them to put their money into. So a user might look at a chart like a TVL chart like Lido and say, okay, this is a protocol that's been around for 2.5 years. It's custodying $15 billion. If I'm putting in 10 million, 25 million, probably okay, because I'm assuming that everyone else has done their homework. And this is actually the thought process that goes through a lot of the users in the DeFi side, because it's so expensive and difficult to make the tie between the audit report and the actual code that's deployed on-chain. We can view smart contracts as custodians of assets and live bug bounties. Smart contracts either are directly custodying assets, for example, an LP token, a lending protocol, a yield management protocol, or they're indirectly custodying assets through wallet approvals. And because these contracts that custody assets are a massive bug bounty, the longer the implementation of these smart contracts is live for, the more lindy they become. But the most important thing is that when we're trying to come up with a metric that defines how lindy a certain protocol is, it's important that we reset that lindy metric whenever the protocol upgrades its smart contracts. And they actually do quite a lot. So here's a simple example of a protocol that launches at time step 0, gains some TVL, kind of flatlines, but issues 2 upgrades. From a traditional user's perspective, they'll look at that TVL line on the left, and they'll think, okay, this protocol has been around for a while, like they're gaining TVL, but the problem is that with the upgrades, the lindiness of the protocol actually resets to 0. So let's get into, I guess, a bit of a spicy territory. Let's walk through an example of a DeFi lending protocol. Most users will look at a chart like this. Things seem pretty good. This protocol is custodying $100 to $200 million in assets. That kind of equates to a bug bounty of $100 to $200 million that's been live for a year. And it looks pretty good. But when we actually dig into the code, so here I'm using codeslaw.app, I can dig in, find the smart contract, and I realize that it actually implements proxy logic. That's actually not standard. I decode the relevant storage variables from the contract, and I pull the history. So for this, I'm using tokenflow.live, which is a EVM data provider. And what we see is that this protocol actually has quite a lot of updates. At the top of the table, you can see the initial deployment as the storage in the contract is being set from 0 to the initial logic. But then subsequently, you get a lot of module and proxy upgrades, because protocols do upgrade quite a lot, especially if they're very early stage. And if we overlay the upgrades with the TVL, we can start to see the issue of just relying on the TVL line as lindiness. So you can see that near December of last year, there was an upgrade that subsequently led to the exploit. But even after that upgrade was pushed, another $150 million went into this protocol before it was subsequently exploited, and then they paused the protocol by issuing another upgrade. Most users will just take the line on the left, the integral TVL, as perceived lindiness, but the security actually resets at every proxy upgrade, giving this more jagged chart. We don't want to give credit when there's new implementation logic. But we think that there is a lot of room for improvement on the audit side, and that the current state of audit reports and the lack of linking between audit reports and deployed contracts is not the future. We think that the future of audits is probably an audit metadata protocol. This isn't a new problem that the web hasn't faced before, and there are examples such as robots.txt or the Open Graph, which are examples of protocols that have standardized previously unstructured metadata to improve user experience. So in conclusion, we collected every audit report on pretty much every audit report on Ethereum DeFi. Very few of these audit reports actually link between the actual code and the deployed contracts. But we think that these first two issues are solvable with a metadata standard. But in the interim, we think that users most likely, unfortunately, end up falling back to derived measure of lindiness. But we think that one way to get around this is by exposing and making more transparent the prevalent nature of proxies and upgradability that is very prevalent within DeFi. And we propose STVL, which is a metric that resets the lindiness of a protocol whenever the logic and dependencies upgrade. Thanks.
Thanks, Ben.